As we're getting ourselves started here, first of all, welcome to everyone who is joining us from all over the nation. My name is Paige Valderrama-Graff, and I'll be facilitating today's session, trying to keep things running smoothly so that you can get a chance to have a virtual tour of NASA's Lunar Curation Lab. We are broadcasting from the NASA Johnson Space Center here in Houston, Texas, and a little bit of an overview of what to expect for today. I'm going to go through just some opening remarks so you know what to expect. Secondly, we're going to hear from our lead speaker. She'll introduce herself. Her name is Andrea Mosie, and she's here at the NASA Johnson Space Center. She may ask you periodic questions during the webinar. If she does, the chat window is the place for you to put all of your responses, and then we'll kind of see the types of answers that you have for Andrea's questions. Now, at the very end of the session, we'll sort of have a Q&A where you can actually ask some questions of Andrea, in particular, of any questions that might have arisen during the webinar itself. Now, Andrea is an extremely busy individual, and our Lunar Lab is a working laboratory. So she will only be able to stay with us on the line till about 50 minutes past the hour. And then myself and Suzanne will be able to stay on for any lingering questions we may have from you. Now, I want to officially welcome all of our participants. We actually have 22 states. I just had a recent registration from a group in New Mexico. So for the 22 states, as you can see this map here, from literally all parts of our nation. We have some openings. We want to get some groups from some of these states we haven't yet connected with, but 22 states plus our group from Mexico. We have students or individuals on the line that span from K through 12 plus, so maybe some university students as well as some adult educators. So we welcome all of you today to our webinar, the virtual tour of NASA's Lunar Curation Lab. Now, again, as I mentioned, Andrea Mosie is our lead speaker. And here's a picture of Andrea in the lower part of this screen on the left in blue. Andrea is one of our lead folks in the Lunar Curation Lab, but there are other folks that may be joining her today. One for sure, right next to Andrea, is Suzanne Foxworth. She is helping to facilitate this webinar from the Lunar Lab. Other lunar curators that you may or may not see, I'm not sure if they're going to be in the lab, but we've got Jeremy Kent and Cherie Kreischer. Linda is another gal who may be joining us or may be in the lab. I don't have a picture of her here, but we've got quite a few people that work in our lunar lab. But Andrea is our lead, and we're going to let her introduce herself in a moment. The last thing I will mention is perhaps you remember that last week, goodness, was it just last week? Last week was International Observe the Moon Night. Hopefully you had a chance to look up at the moon, but if you didn't, in our opinion, every night is Observe the Moon Night. So anytime you're out there, look up at the moon. When you see it, perhaps you'll think of the lunar rocks that you're going to get a chance to see today. There's a website there, observethemoonnight.org, to find some additional information, as well as our Aries website if you want to go there as well. Now with that, again, I welcome all of you, literally our groups from Texas, Florida, Alabama for the first time, North Carolina, Illinois, Iowa, Texas, New York, New Jersey, Georgia, Oregon, Tennessee, Michigan, Arizona, Maine, Ohio. Hopefully I didn't miss your state. We're so glad that you're able to join us today. So with that, I'm going to turn things over or take us to our Lunar Lab for some introductory information about our Lunar Lab. So Suzanne, if we can turn things over to you, I'm going to see if I can get your camera up, and then we'll turn things over so that we can hear from Andrea as she introduces herself. So again, thank you, Suzanne and Andrea. And Andrea, I'm going to turn it to you to take it away.
Thank you, Paige. Good afternoon. My name is Andrea Mosie, and we're at NASA Johnson Space Center And the building that we're in is the Lunar Sample Laboratory facility. And right now, this particular laboratory is the Pristine Sample Laboratory. And this is the lab where the samples that were brought back during the Apollo mission are curated. I am actually from Houston. I think that's my first slide. I'm from Houston, Texas. Attended high school at Edmonton High School, graduated with a class of 71. I attended Houston Tilson University in Austin, Texas, before becoming employed here and started my career at NASA Johnson Space Center. I've been on 3 science and engineering contracts. Now I'm with Geocontrol, which is a part of the Jacobs Group.
Next slide. 3. Slide 3.
I'm actually a scientist here, and what I actually do is work with rocks from the moon. There were 6 missions that went to the moon, bringing back 842 pounds of rock. And before working here, I actually always liked science and math. So it was determined when I was at a very young age that I would probably go into the sciences. I actually changed my mind while I was in school, and I decided to become a doctor. But at the last moment before graduating from college, I changed my degree for pre-med, and I got my degree in chemistry and math from Houston Tilson, applied here at Johnson Space Center, and I have actually been working here for 42 years since graduating from Houston Tilson. Prepare yourself for the future. Well, I was always a studious person, but I was a copycat pusher. I'm the 4th child for my mother and father, so I actually had an older sibling that was really good at math and science. So everything that she did, I did. So it's important to find you a good role model or someone that you actually can look up to. May not necessarily be a family member, but someone that you can look up to or someone that can lead you toward what you really like to do or what you think you may like to do in life. You can always change your mind. You don't have to decide now what you'll do for the rest of your life. But the goal that I set and the career that I have, I really am happy that I decided to do that.
Overview.
Okay. As I stated before, there were 6 missions that went to the moon from 1969 to 1972, bringing back 842 pounds of rock samples and pebbles. They collected rocks on those missions, and once they came back to NASA Johnson Space Center, they went into the first facility that was built for housing them. Those samples actually went into quarantine so that they could make sure that they didn't bring anything back that was going to be harmful to human life or to Earth. Once they found out that they were not anything bacteria or anything harmful, then we put them into cabinets that are nitrogen filled, that have positive pressure, because now we're actually protecting the rocks from us. I think on your next slide, you'll actually see the lunar module on the surface of the moon. You'll see how the surface of the moon looks, gray tones, and you'll see a picture of the astronaut. And the astronaut will also see the apparatus that he's carrying on his back. They had to make sure that the astronaut gear would protect them for the atmosphere on the moon. They had to be protected. Of course, we need oxygen to breathe, and there was not oxygen enough for astronauts on the moon to sustain life. So they have their own oxygen tank, and they're protected because there's also debris that can be coming in from meteorites or other planetary bodies, and they want to make sure that the astronauts were protected from those as well. In our sixth slide, the United States was first to be present on the surface of the moon. That was the goal of our President, John F. Kennedy. There was a race to get to the moon first. There was a race between the United States and the Russians. And of course, in 1969, we were successful and we landed first on the moon. Our first astronauts were, and maybe I should ask you that question. Who was the first astronaut that landed and walked on the moon? Give me two, the first two answers.
All right, so that's a question for you all in the chat window. If you can name the first astronaut or the first or second astronaut that landed on the moon, we'll see what we come up with. So Stockholm Middle School says Neil Armstrong. Ford Elementary, Neil Armstrong. Let's see if we get any other additional names that might come in. From our solar system ambassador on the line, I'm seeing Buzz Aldrin. Our Lady of Perpetual Help Catholic School says Aldrin, and that would be Buzz Aldrin. Cross Timbers says Neil Armstrong. J.A. Throws, Aldrin. E.M. Daggett says Neil Armstrong, and Buzz was second. So they're actually giving us an order there. Alexander Middle School says Neil Armstrong. And we'll see if we have anyone else. Murfreesboro, Frank Long Elementary, they are both also saying Neil Armstrong, and Frank Long added in Buzz Aldrin. Carruthers and Mr. Todd's group, Neil Armstrong. And actually, Our Lady of Perpetual Help says that Collins stayed in the Apollo capsule. So we have some additional Harrison Intermediate, Cardinal Gibbons. They're mentioning Neil and Buzz and Michael Collins as a third individual. So, boy, Andrea, I don't know if I would have known this during my middle school or elementary school years. Who was the first, the second, and what about this Michael Collins?
All of that information is absolutely correct. Neil Armstrong was the first, Buzz Aldrin second, and Michael Collins did stay in the module orbiting the surface of the moon. Absolutely correct. Thank you.
Next slide.
Our next slide, view of the moon from the Earth. So you see the one that is the surface of the moon, and that's obvious. But the next one they call moonrise. So it's a view of, it's a view of the Earth from the moon. The astronauts took that picture of the Earth, and it has actually gone everywhere. You will see that particular picture everywhere. That's the surface of the Earth, and you can actually see the colors. You see the blue for the water, and so you can see the colors of that. On our next slide is actually an astronaut holding one of the sample containers that they collected samples with. They had certain specific tools and containers to use, and if you can see in the shield, you can see the other astronauts. There were 3 astronauts on every mission, but only 2 astronauts from each mission actually walked on the surface of the moon. And again, you see the flag that was planted, showing that we were first to make it there. But for every mission that went to the moon, a flag was planted on the surface of the moon. So actually, and I think I kind of gave this away before, how many samples do you think that the astronauts collected? I think I said this, so how many samples did the astronauts collect?
Now, Andrea mentioned how much they weighed, but in numbers, how many original lunar samples do you think astronauts collected from the moon? So Frank Long Elementary jumps in with 235. Let's see how many other folks give us some potential answers. So the number of original samples collected from the moon, and we house these samples. So Cross Timbers says 500. J.A. Throw says about 800 pounds. Cardinal Gibbons says a total of about 255. Stockholm Middle School says 350. Athens Intermediate says 175. Miss Baus says 150. Ian Daggett, 175. Our Lady of Perpetual Help Catholic School says 814. That's our largest number yet. Murfreesboro says 235, which is seemingly a very popular answer. Harrison Intermediate says 85. Now remember, there were 6 total missions that went to the moon. Now Alexander Middle School has jumped in and said 1,000 original lunar samples were collected. So that, I believe, is our biggest number yet. And so 6 missions, how many samples? Andrea, is anyone close?
No. Much more. Actually, 6 missions, and every mission brought back more samples. 382 grams, 842 pounds, almost 2,200 rock samples, rock, soil, and pebbles. So it's 2196, almost 2,200. So that's a lot.
And did those samples stay as 2,200, or have they been since subdivided?
Those samples have been subdivided, and now we have over 100,000, closer to 120, 25,000 samples, way much more than 100,000 samples. And they're processed here in our Lunar Lab, and during this tour, I will actually show you the splitting process. So we'll start our tour off looking over at one of the cabinets that we have samples in. We actually have 5 different types of rocks. Now, we don't mix missions in cabinets when we're processing samples, but in this display cabinet, the missions are mixed. The very first sample that you'll see on the end is a Apollo 17 sample. You can look at the rock number, and the number will actually tell you the mission of the Apollo mission. Apollo 12 through 15 actually began with those numbers. The Apollo 16 and 17, they dropped the 1 from in front of that. And with the Apollo 11 sample, it actually begins with the number 10. So every mission has a 5-digit number for each rock. Comma 0 is the parent of each rock. And every time you break a piece, it gets a different number. Comma 1, comma 2, comma 10, comma 100. Every rock piece will get a different number. So back to this first Apollo 17 rock, which is the ilmenite basalt sample, which was almost the very last sample that was picked up when the astronauts left the moon. It's called the Children of the World rock, and when Jack Schmitt picked up this particular rock, he gave it that name because a piece of that rock went to states and countries all around the world, and they were in little acrylic buttons with a flag from the United States that flew on that particular mission. So this first rock, above the top sample, is called the Children of the World rock. It's a fine-grained rock, and it was collected very close to the lunar lander. The next sample that you'll be looking at is what we call an anorthosite sample, and it's Apollo 16 rock. And you'll see that number 60015. It's an anorthosite. Anorthosite is the white rock that you see. You see the white part in there, but it has a glass coating on there. That's because an impact of another planetary body hit somewhere close to this rock. Because of the ejector that went up and the heat that was generated, when that rock tumbled, it was covered in that black glass. And that rock was collected around the area they call South Ray Crater. The next rock you see is Apollo 15 rock, which is also a basalt. Now that's the kind of rock that you'll see around volcanoes. You see the bugs, the vesicles there? And this rock has a particular story because it's called seatbelt rock. Can you get it around this one? Okay. This particular rock is called seatbelt rock. And the story is Apollo 15 was the first mission that had the rover, and the astronauts could only drive out so far that mission control would say, you have gone as far as you could go, you need to come back, because if the rover failed, they had to be able to walk back to the lunar margin. When they were getting ready to come back, Dave Scott actually looked over and saw that particular rock, and he was very interested in it. So he wanted to go and collect that rock. But NASA said, no, come back. You've gone as far, you've exhausted all of your time. And they told him to come back. He did not obey. Actually, he got off of the rover while Irving was telling this story, kind of making up a story, just talking to the guys back at Mission Control. Dave Scott got off, went over to this particular area where he saw the rock, put in his documentation stick, took a picture of the rock, which is what they had to do for all the samples, put it in the documentation bag, and made it back to the rover. And all that time, Irvin is still talking to Mission Control, telling them a story about whatever he's making up. And they said, okay, you guys come back right now. So they said, okay. He said, as soon as I get my seatbelt fastened. He hooked his seatbelt. They got back on the rover, made it back to the lunar module. Once they got back to Houston and to the laboratory where they're taking out all the samples, all of a sudden every rock was accounted for, but there was one extra sample. They pulled it out and they asked about this rock. When they asked about this particular rock, Dave said, oh, funny you should ask about that. And he told them the story. So they actually gave that rock the name Seatbelt Rock. So that rock is known all over as Seatbelt Rock. The next rock also has a name. It's the largest sample that was brought back during the Apollo 16 mission. The two to the right, the two samples those are breccias. This one is a melt rock. It has a big white anorthosite, which means that's the white rock, on the cap of it that has been broken out. But this rock was like football size. There were special tubes for picking up samples and putting them into the dock bags, but this rock was so large that none of the tubes would work. So actually it had to be rolled up the leg of the astronaut suit. He almost fell over trying to collect the sample. He put it in the bag, but as he was collecting the sample, he actually said the words, if I fall into Plum Crater trying to collect this rock, Mohlberger has had it. All that information is in the voice transcript that came back during from the astronauts' visit to the moon. And in this particular rock, when they were speaking of Mohlberger, he is a geologist who actually taught the astronauts, Apollo 16, their geology. William Mohlberger, who was a professor emeritus until lately at University of Texas in Austin. So Big Muley is actually named after Bill Mohlberger. Now the next rock you see on the end is a regolith breccia. It's Apollo 15 sample. You see all the different rocks and pieces on there. Regolith is the soil or the top surface of the moon that has actually been bombarded and beat up by planetary bodies and meteorites for billions of years. So this rock is basically a collection of that all welded together. So all those little pieces you see in there, if you were doing age dating or if you want to know how old this rock is, all those pieces in there are pieces of older rocks that formed into another sample. and the outside exterior of that is actually a younger age than those pieces in plastic you see inside there. Now you see that cube that you see there? It says NTE SB, north, south, east, west, top, and bottom. It's one by each of those samples. The astronauts actually took pictures of the rock on the moon and gave them an orientation, lunar north, south, east, west, top, and bottom. And that's very important because we have to take pictures of every sample. Our process is to weigh the samples first to make sure they are within the balanced tolerance before processing. We have to take pictures of the rock, and we actually orientate them back to the same orientation that the astronauts had when they picked up the samples on the moon. Now, every sample that was picked up did not have an orientation, so we will give them a lab orientation. Once we give them that orientation, we keep that orientation throughout the entire process of working on a sample. Now, the rock that you see on the end to the right, and Suzanne is showing you those again, I'm going to pull out what we call a data pack and show you the process that we go through.
Someone wanted to know why they're in bags.
Oh. Those samples are in bags right now, and they are not always in bags, but this is hurricane season. And during hurricane season, every sample has to be bagged up and transferred into our vault area for protection in case we have a nitrogen failure, a shutdown, or whatever. It goes into what we call dead mode within the cabinet, and the nitrogen in the cabinet is filled in there, but for extra protection to keep the samples safe, we put them in these Teflon bags. And so that's why these are still in Teflon bags, but usually those samples would not be in the Teflon bag. So we're going to come right over here, and these are data packs. Data pack records the history of every sample. And one rock could actually have as many as 10 or more data packs. Now the rock on the end was Apollo 15, 15459, and this is the data pack for that rock. And I'm going to go through a process. Now these were done a very long time ago, and all of these data packs have been scanned, and all the information is downstairs in an area we have a data vault. So everything has been collected, and everything is there for historic purposes and for research. We have what we call a curatorial order, and now these, of course, are typewritten, and it's done by, signed by our curator at the time, and it actually tells you what process you need to do for the sample. And the very first thing you have to do is see what the weight of the sample is. And you can see right here, at the particular time, it was 3743 grams. And we weighed it, and it's within the balance tolerance. So that means you can continue to process. Now, this is actually something that I worked on in 1985. I'm an ABM. Okay. So the first process is, and this is a bandsawing process. We have a bandsaw, which is a nitrogen cabinet, and in that nitrogen cabinet, it has a diamond edge blade because it makes a dry cut. You cannot use any oils or lubricants because that would contaminate the surface of the sample. So this is a moving slide that it's sitting on. That's a moving slide. And you see, of course, the cube. That's the bottom. And all of these little washers and everything you see touching the sample is either Teflon or aluminum. Those are the only kinds of materials that we actually touch the samples with. And so this is the first photo, and you're actually just setting it up to make the cut. And you're looking on the B1 side, but then you take another picture on the T side. So you take a picture on both sides before you begin to make your cut. Now, every time a piece falls off, You see that little piece that fell off? It gets a number. This one is 244. And on the next picture, pieces have broken out 245. And we give them description. 2 dock chips, 1 LOC chip. Now, a dock chip means that I know if it's north, south, east, west, top, and bottom. LOC, locatable chips, means I know it came from that spot. I just cannot tell you the direction that it was. So it's important that you document everything. And you'll notice as we continue to go back, pieces are continuing to break off, 246, 248, 49, and so forth, so on. And that's very important that you take pictures as you go along and document everything. You can see every picture, and it just kind of looks like it's crumbling because you never know if there's a fracture within the rock. The good thing about technology now is we can CT scan the rock and we can actually see what's inside of the samples. Because if you see, this is our reconstruction picture. You see how that's put back together where you know where every piece is coming from. And let's just say that this little white class, which you know is an anorthosite, was given to a scientist to do his research study, and this is the sample number that it came off right there, which is 259. He used up all that sample, but now technology and instrumentation is so much better that someone is doing that same type of analysis, and they want that sample, but it was used up. You'll see over here on this other piece of rock, which is comma 252, there's also some of that same anorthosite remaining. That's why it's so important that we document every part of the sample. Here's another picture on the opposite side showing you where all the pieces came from. And now, we scan this one. That's why my face is coming out. We also collect all the chips and fines and the soil. All of that's good sample because all of that has to add up to balance in the end. You have to have a balance. Every sample will have a weight. Every sample will have container number, dunnage if needed. Everything has to equal up. So when you finish processing, if you started off with 3,400 grams, in the end, when you add everything in within your balance tolerance, you have to come out balanced. All samples have to balance.
Now, Andrea, if I could interrupt you for a moment, a couple of really interesting questions came up from you showing this cutting action and how many pieces can be cut. So 2 questions. One is, how long does it take to do a cut? And the second is, why is it always important to know the orientation?
A cut could take anywhere from 15 minutes to a couple of days. It depends on the size of the rock, how hard the rock is. Some rocks are very hard. You may even need to change a bandsaw blade if, in fact, you're trying to cut a sample and all the diamonds have worn off and it's not making the cut. You may have to change a blade. So this particular rock probably took a couple of days because pieces were falling off and you have to stop. The importance of that is for the studies that the scientists are doing now, and we call them PIs, which is principal investigators. The studies that they're doing now, they want to know about cosmic rays, solar wind, so you need to know exactly how that sample was sitting on the moon. But if that sample is broken, and you need to know as far as magnetic, what's facing up, lunar north, south, east, west. So depending on the type of studies that the researchers are doing, they actually absolutely need to know exactly how those samples were sitting on the moon. So that's why it's important to know, even after you've broken them up into all those pieces, how they were actually oriented on the moon.
Thank you so much for answering that, because those were great questions that came in, and as you can tell, the details of everything gets documented for research purposes. So every piece of information is so important. So thank you, Andrea, for answering that. And just so you know, it is 20 minutes to the top of the hour, so I know you have some time constraints. Just letting you know.
Okay. While we're right here, we'll let you look at another sample, which is Apollo 16 sample. And it has a glass coating like we actually saw. It was actually set up to be a display, and it was a display. We had to dismount it, and it's going to be taken apart, but it's a very beautiful sample, and we call it the egg. And you also see the anorthosite. So it has a glass coating, and you also see the anorthosite. So you notice the types of rocks we said we have. No. What types of rocks have we said we have?
So I think that's a question for you all now. Is that correct, Andrea, that you wanted to?
What's the three types of rocks?
So for those of you out there, this might be a little difficult. Andrea mentioned 3 different types of rocks. So Our Lady of Perpetual Help Catholic School says igneous, Miss Faust class in Ford Elementary, basalt. Alexander Middle School, basalt. Our Lady of Perpetual Help Catholic School says anorthosite. Cardinal Gibbons mentions the possibility of metamorphic or sedimentary. Cross Timbers mentions igneous basalt. Murfreesboro Middle School says anorthosite and basalt. Sacco Middle School says igneous metamorphic basalt. So I'm seeing some earth-related kinds of terms here. Frank Long Elementary says basalt. Coles Montessori says igneous and metamorphic. Frank Long, I mentioned, says basalt. So I'm seeing igneous, metamorphic, anorthosite, basalt. There's one that I'm noticing that's missing, but Andrea, what do you say in terms of igneous, metamorphic, and these basaltic additions there?
The one that was missing was the breccia.
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 Now, would igneous and metamorphic and sedimentary, do those 3 types of rocks exist on the moon?
They're not called.
So they're not called that. However, the anorthosite, the basalt, and the breccia, as she mentioned, are those 3 classifications. So a little different from Earth, but some similar processes in some cases. And a breccia, for those of you who might be wondering, that's that mixture of a rock. If you remember one of the samples that had gray and white sort of all mixed together, those would be considered a breccia, where it's a mixture of multiple types of the lunar surface kind of mixed together. And we sometimes call them impact breccias.
It's the one that I called the regular breccia on the end, which was the 15 that I showed the data pack for.
Awesome. This looks interesting.
This is the oldest rock. This is the Apollo 15 rock that's called the Genesis rock, picked up by Jim Irving and Dave Scott, of course. And when they found this rock, I actually want to read this to you. They were so excited, I printed this off to read it. If I have it right here. They actually had a conversation once they found this particular sample, because this is actually what they were looking for. They said, I think probably, could we break off a piece of the card underneath it? Or I guess we could probably lift that top fragment off. And they said, the commander said, yes, let me try. Yes, sure, it's a white class. They're so excited. They said, oh boy, look at this glint. Almost a twinning is there. And that's the kind of thing you see when you look at minerals. And they said, guess what we found? Guess what we just found? Now, they're talking back to NASA because they're so excited. Crystal rock, huh? Yes, sir. You better believe it. Look at the plage in there. Speaking of the plagioclase, which is the white mineral there, ourselves something close to a northern because it's crystalline and there's just a bunch. It's just about all plaids. What a beaut. That really is beautiful. And there's another one down there. Yes, we'll get some of those. No, don't mix them. This one is a special one. Let's zip it up, make this bag special. Our first one. Don't lose your bag now, Jim. Oh boy. I mean, they were so excited once they found this particular sample. They were so excited because this actually dates back 4.5 billion years, and that's what they said. This is why we came to the moon. We were trying to find something that dated back to the original formation or the original crust of the moon. Now, just because we may not make it the whole time, we're just going to turn this way, and we're getting the vault open. Just to let you see back into the vault. We have one of the techs who's actually coming to open our lunar sample vault because we have to pull samples for a PI that will be coming into our laboratory on next week. So this one you can see that as he was going back into the vault. I have one more sample right here that I'd like for you to see as well. And this is a Apollo 17 sample. This is my favorite rock. So I'm hoping that you can see it very well. Why do you think this would be my favorite rock? Any thoughts?
So in the chat window, why do you think this is Andrea's favorite rock? Now this is pretty special because Andrea working in this lab over 42 years. I mean, she's got a favorite rock and this is it. Why do you think this is her favorite? Let's see what we get from our students. Our physical health says it is Cardinal Gibbons says made of different types of rocks or breccias. The Ford Elementary Group says it was the first one ever taken. Frank Long mentions maybe because it's rare. Coles Montessori says, did you classify it maybe? The NMMSH in New Mexico says because of the multiple surface areas. J.H. Rose High School mentions maybe because it's the same color as the moon. Cross Timber thinks maybe because there's crystals present. Garza Elementary agrees. It kind of looks crystal looking. Saco Middle School says maybe you like it because it's unique. Ford Elementary says maybe it's the first sample you got to work with. Murfreesboro says it's broken up and has different rocks in it, so maybe that's why you like it. Mr. Todd and the Carruthers Elementary Group says maybe because it's crust. So we have things from it's crystal looking, it's unique, it's your first rock you got to work with. Why is this your favorite, Andrea?
Actually, it's the most colorful. It is crystalline, that's true. It's kind of like all of the above. It's crystalline, it broke up easily. You can see the anorthosite, those minerals that you see in there. Plagioclase, pyroxenes, olivines, those are the different minerals. And we do have those same minerals here on Earth. But this is the only rock that was brought back from the moon that you could actually look at with the naked eye just like this and actually see the colors like that. So it's considered, it is a colorful, pristine, coarse grain sample. And so it's basically all of the above. But you see how beautiful this is just looking at this sample with the naked eye. Can you see that very well?
And we can, and that is, I didn't know myself that this was your favorite sample, so I love the fact that you're sharing that with us.
And this particular sample, and you notice that the samples we've been showing you were bagged. That's actually because for even every mission that we go over to, If another sample is open in that cabinet, being worked in that cabinet, even though they're the same mission, you cannot have different rocks open in the cabinet at the same time. That's a form of contamination. This one is crystalline. The other one may be a regular breccia, even though it's from the same mission. You cannot have those because that would be cross-contamination of samples. Now, if we walk right over here, and I probably did not do this, every sample is by mission, and this is the Power 17 cabinet. We work inside of these cabinets, and this is the way that we actually do it. Everything in here is Teflon, aluminum, or stainless steel. Those are the only types of material that's allowed in the cabinet. I'm going to step back so they can see the bunnies too. Okay.
And those gloves are sticking out because of the positive pressure. These are nitrogen-filled cabinets, which help make sure that these samples are not changed in any way, and nitrogen is considered basically an inert gas. So I'm going to turn it back to Andrea here.
Yes, when the samples first came back, as I had mentioned, they were in a negative environment, which means these gloves would have sucked in, and the reason was in case they brought something back that was a contaminant, then it would have been contained. But now we're protecting the samples from us. So that's why they're under positive pressure and the gloves stick out. And this is another Apollo 17 sample, but you notice that the one that I showed you, my favorite, this one is an northern-site, and that's why we don't open with one type of sample. You see how different it is from the one that we just showed you. And if a piece of this got mixed up with that, and you're doing analysis of where something was located on the moon, where they found it, and you've mixed this up with the other part, then your analysis will not come out correct. Because you're thinking on the moon at a certain place, a certain type of rock was found, but it's actually you contaminated by cross-contamination. So we have several rocks in here. So we actually cannot see them all, so there's another one. And actually, that's actually another piece of 76535. Remember that number, that's my favorite rock, 76535. And you'll see we break the samples. This is a hammer. We have chisel. We have different kinds of tools in here. And I'll just show you some of the tools. We put all the samples that we're working on in aluminum cups. We'll put the little number in there so every time we break a piece, we'll know the different number that goes in there. These are different kinds of containers. These are called number 9 containers, and they have a serial number scribed on them because everyone will have a different number. And you notice that all the tools are bagged. When they came into this environment, they're cleaned in our clean facility outside. They're actually triple bagged. Once they come up to the lab area, this area right here is our quarter around the lab. Once we get to this door outside, and we get ready to open this, and when I say outside this laboratory, but the quarter that's going into the vault, we cut out one bag, and then we put it into this chamber, and we purge this for 5 minutes before opening the door and bringing the tools in. We cannot touch the tools with the same tweezers. You actually have to use different tools and containers and tweezers for every rock that you work on. You don't use the same one. So we have different special tools like scoops that you scoop up soil with, other kinds of little containers. We call them PVs. And depending on the size, we have larger containers and even much larger containers. One more thing I'll show you that I see is a Teflon glove. If I'm working on that sample, even though you see that I'm dressed in a bunny suit and I have on gloves, I'm working inside of this glove box or cabinet with rubber gloves, or it's a neoprene glove. I still have to put on an additional glove on the top of this in order to pick up the sample. You cannot touch the sample with these gloves. The only way I can pick them up with these gloves is if they're already bagged. If the sample is open, so these samples have never been touched with their hands. So why do you think we don't touch the samples with our bare hands? I just thought that.
That's a great question, Andrea. So for those of you out there, why don't you think we touch the samples with our bare hands? Frank Long Elementary says contamination. NMSH says because of the oils. Alexander Middle School, so you don't contaminate those rocks or get them dirty. Our Lady of Perpetual Help Catholic School says we have oils on our hands. J.H. Rose also confirms we don't want to contaminate them. Mrs. Bouse's class at Ford Elementary says the oils on your hand will contaminate the samples. And Murfreesboro Middle School adds in there, we don't touch them with our hands because we want to avoid contamination.
Absolutely, and those are the correct answers. We don't want to contaminate the samples with oils on our hands or makeup possibly from our faces or whatever else we have touched that we bring into the lab. So that's why we're actually working on those in this clean room lab. And this is actually a class 1,000 clean room. Number of particles per cubic foot less than 3 microns. So we keep everything in here clean so we can protect the sample. Our goal is to protect the sample for present and future research and educational purposes. So I think we have, you can actually see I think we had a picture of Cherie. We have some of the other processors who are actually dressing now to come into the laboratory to do some of the processes that we're doing. So that's Cherie. I think we had a picture of Cherie showing up. And that's Cherie. She'll be coming to the laboratory because we're doing this sample. So the reason that I'm covering this, that's the question. Why am I closing these up and covering them with a little white cover?
So that's a question for you all. Why is Andrea putting these little white caps on these gloves? Let's see what kind of answers we get on that one. She's rolling them up. She's covering them almost with like a little hat. Why? Let's see the types of answers we're going to get. So Frank Long Elementary says for safety. Let's see if any other answers come in. And that is actually quite an intriguing question. Carruthers Elementary says to add extra protection. So we'll see if we have any others. The Ford Elementary in Ms. Bouse's class says to keep them clean. We'll see if any. Alexander Middle School says to protect the black gloves. Cross Timbers has an idea about keeping the gloves from contamination. Coles Montessori says to avoid getting the gloves to avoid getting them dirty. Murfreesboro says to keep them from sticking out so people aren't touching them. Let's see if we have any other answers. And what's special about this is people in general cannot get into this lab. This lab is specific to our lunar curators. Very few people get into this lab. Joining even Andrea and Suzanne in there virtually is very, very special. So this is not open to many. So let me get back to my answers here. NMMSH says to prevent damage to the gloves. So Andrea, why did you put those little white things on the gloves?
Actually, this is a secure lab, and there are security reasons, and we are still in protection mode and safety mode, so that's correct. But after we closed our lab and locked our lab, everything was alarmed. So if a glove would happen to move, it's going to set off the alarm. And security is going to come over because they're going to think somebody's trying to steal or break into our lab. Our moon rocks are a national treasure. There's no monetary value that we can actually put on them because they are actually priceless. And so that's the reason that we go through all that we do to protect them to protect them from us, actually. So, and this is Sharice. Sharice is one of our processes geologists. And up here we're getting ready to pull samples. And we're actually getting ready to...
So she just came through the air shower.
Yes. And the process of dressing and coming through the air shower is what we do. You stand up for 1 minute. Every room is pressurized so that the clean air is going out. So that the dirty air, so every room you come into is a greater pressure. You cannot tell it, you cannot feel it, but it goes out so that no air from the outside ever comes into the light.
Now, before we let you go, Andrea, because I know your time is limited and you've probably exceeded it, but let me tell you folks, Andrea being here for 42 years or so, you would never know it because her joy, her passion for what she does is amazing. And that kind of flows over to the rest of the folks, including Sharice and even Suzanne and I. Now, Suzanne, if you just sort of pan around the room for a second so that I can ask Andrea, this Lunar Curation facility, why is it special to you and why do you enjoy working here so much?
This is actually the only place, in the world that has the amount and number of lunar samples that we work on a daily basis. Now, I may not be in the lab days. Sharice may be in when I'm not in or whatever, but this is the only place that you can handle and work with priceless samples that were brought back during the Apollo mission. And it's total joy. It's total joy. I enjoy it as much now as I always have.
And we so appreciate your time. And for all of the folks out there, this is a world-class facility. This is a unique facility. There is not a facility like this in the world, as Andrea mentioned. And so this is so, so special, and very few people get sort of on the inside. So, Andrea, thank you so much for sharing your knowledge, your passion, your expertise, and for bringing us into NASA's Lunar Curation Lab. We so appreciate it. And Sharice, thanks for stepping in so they could see another individual, another one of our female scientists who works a part of the lab as well. So I see that it is just past the top of the hour, so I know Andrea has to run. And for those of you that, and I'm going to see if I can return back to, it looks like I'm going to go back to sharing my video. So for those of you that are still on the line, first of all, I want to thank you for joining us today. And I also want to mention that, again, we are so thankful to have had Andrea being able to, and I'm going to see if I can pin my camera here, to share with us the Lunar Lab, because it is such a special place. I'm going to also mute that line. Maybe Suzanne, there we go.
Bye. Thank you. I enjoyed it. Hope you enjoyed it.
Thank you so much, Andrea. And as Andrea is getting ready to leave the lab, again, we appreciate you, Andrea, and your time so very much. So thank you very much, Andrea. And Suzanne. Now, for those of you, again, I realize it is at the top of the hour, so many of you have to depart. If you have some remaining questions that I can potentially answer for you, I'd be more than happy to try to answer those questions. And again, I have to say that the Lunar Lab is a very busy place where these folks, their everyday job is working with these lunar samples, working with these lunar rocks. There are many people these days that, you know, they don't stay in a job for 42 years at a time. Andrea has been a part of this facility and this lab for over 42 years. And again, we are so thrilled that we were able to share our lunar lab, Andrea, and the wealth of materials that we have here only at the NASA Johnson Space Center.